Here is an identity. Again, n choose r or n choose k, which is the number of combinations of n objects taken k at a time, those are also called binomial coefficients. And why that terminology will be clear in a bit. Here I have an identity. What I'm saying in this identity is that n choose r is the same as n minus 1 choose r minus 1 plus n minus 1 choose r. Okay? Does anyone have a proof for me of that? Can you prove that identity? One, proving this identity by using discrete argument or counting argument would be to show that both sides are counting the same thing. So can you argue with me that both sides are counting the same thing? What is the left-hand side counting? The left-hand side is counting what? The left-hand side is counting what? Well, that means the number of ways of picking 3 out of n, right? Sorry, not 3. Picking r out of n. Or I can say this is the number of subgroups of size r taken from a group of n elements. Number of subgroups of size r taken from a group of n elements, right? That's the left-hand side. Can you argue that the right-hand side is counting the same thing? Is the right-hand side counting the same thing? So you are counting the number of subgroups of r elements taken from a group of n elements, right? That's what you're counting. Well, imagine that you have n elements, right? I don't know, let's call them A1, A2, ... an. So I have n elements, and so we are trying to count the number of subgroups of r elements taken from this set of n elements. Okay, one way to count that is, do you agree that, let's focus on A1. There are subgroups there are subgroups that contain A1, and there are subgroups of R elements that will not contain A1. Is that making sense? Let's say R is smaller than n. R is smaller than n. If R is exactly n, right? What is the answer? If R is exactly n, what's the number of subgroups of n elements taken from n elements? One, right? How many committees are possible if I take all of you? Only one, right? So let's say R is smaller than n for a second. So there are subgroups that will contain contain A1, and there are subgroups that will not contain A1, right? Okay, can you tell me how many subgroups will contain A1? How many subgroups will contain A1? How many subgroups of R elements taken from n elements will contain the specific element A1? How would you count that? Well, start by putting A1 there. So A1 is there, right? Okay, A1 is there. So how many more do I need to pick? R minus 1, right? I'm trying to pick subgroups of size R. If I already picked A1, I need R minus 1 more. And R minus 1 from how many? I want to pick r minus 1 from the remaining n minus 1, right? So that you see I have n minus 1 choose r minus 1. So this is n minus 1 choose r minus 1 is the number of subgroups of size r that contain A1. Okay? How about the other one? Well, that's counting the number of subgroups that do not contain A1. Why? How would you count the number of subgroups of size r that do not contain A1? Well, A1 is not going to be in your subgroup, so get rid of it from your list, right? How many do you have left? N minus 1. From n minus 1, you want to pick r elements, right? So n minus 1 choose r, right? N minus 1 choose r is exactly the number of subgroups of r elements that do not contain A1. Is that making sense? Okay, so that's the proof of the identity. Binomial theorem. This is exactly why n choose k is called the binomial coefficient, because if you look at x plus y to the power n, x plus y to the power n, that's the same as the summation k going from 0 to n choose k, x to the k, y to the n minus k. Okay, now if I write it in expanded form, what is that sum? That sum would be n choose 0. By the way, what is n choose 0? Well, by convention, n choose 0 will be 1. Okay, n choose 0 will be 1. N choose 1, and then this should be x times y to the n minus, this will be x to the 0, right? Sorry. So this would be x to the 0, which is the same as x at 1, and I get y to the n, plus n choose 1, x to the 1, y to the n minus 1, right? Plus n choose 2, x to the 2, y to the n minus 2, plus dot dot dot. And what's the second last term? It will be n choose n minus 1 times x to the n minus 1, x to the n minus 1, y to the 1. Plus the last one would be n choose n. N choose n is 1 again, and then this would be x to the n. Okay, so that's what that sum is. Is everybody okay with that? Okay. Are we out of time? Okay, so we are almost done with combinations. The homework that I gave you today is some of them could be a little bit tricky, and make sure you start them right away.